No?
Yes.
So there you must have said no, I think. Just check. Okay. So this type of technical problems we may come across. We are also not sure what actually is going on. Can you see this screen, all of you? Somebody can say yes or no.
No, sir. No, sir.
No, you can't see now this screen. What you
No.
see now? What you see?
Uh, Only the symbol of N.
Symbol of M.
N.
N. Okay, okay. Let me check once again. This type of problem will be there in the beginning. Now I think yes.
Yes, sir, is visible.
Right. Okay. All right. So welcome once again. I will be dealing with the subject design of machine elements 1. I will ensure, I will try to the level best that whatever is important just to be conveyed to you will be conveyed to you during this entire online processes. So to start with, I must say that this is a very fundamental subject, very much fundamental. Actually, there are 3 subjects: machine design 1, machine design 2, machine design 3, and the names may be different. Just like this machine design 1 is here, we call it as design of machine elements 1. Similarly, in second semester, we will have design of machine elements 2. And in final year, we will have the mechanical system design. All these subjects are actually single subjects. You can say single subject divided into 3 volumes because of large content of this course. So this is a very first part in that series, you can say. That's why I said that first part, first subject in this series is this one. Okay, if I some scribble on this, can you see this with red pen?
Yes, sir. Yes, sir.
Yes,
It's
sir.
visible.
Yes, sir.
This is also important. The subject is also important because if I come across with the variety of questions which are being asked, during the oral questions or interview questions, which are based on actually design subjects. So 90% of the questions are actually on design 1 only, because this subject forms the basis of all other design processes. I also must say that this is an extension of the strength of material, because what we studied in strength of material, the all equations we are actually going to use in the design of material elements. Okay, but this you can say is an application of the strength of material. I'll give one example. For example, suppose there is a tensile bar. Suppose if I draw one bar, this is a bar and subjected to some axial tensile force. Now this is known to you. This axial, what is axial tensile, etc. I need not explain, I think, because this is all a part of strength of material, and I hope you all understand the strength of material very well. So this is a simple bar subjected to some axial tensile force, right? Now, what we do in strength of material, we understand that this is tensile force. That's why the induced stress is a tensile stress, and that's why we tend to write one equation. I think this way is equal to sigma t is equal to some force divided by cross-sectional area. This way, right? Now, in a typical strength of material problem, this P is known to us. So this is P is known to us, and this diameter is also known to us, and thereby we know the cross-sectional area A. So this is known to us, and we find out the sigma t. This is a typical problem in the strength of material where we want to find out the stresses. If I want to convert this typical strength of material problem into a typical design problem, what will be there? This sigma t will be given to you. Now, how it is given to you, we can elaborate at some later time how it will be given to you. But sigma t is given to you, force is given to you, or if not given, indirectly something is given so that you can calculate the force P, and then this area is equal to pi by 4 d square for a circular cross section. So I repeat once again, if I want to convert this typical strength of material problem into a typical design problem, the equation remains again same, right? But then now this area, which is a function of diameter d, becomes unknown, and anyhow we try to find out the diameter d. This is a general difference between the strength of material and the design of machine elements problem. Of course, you will also see some of the problems in design wherein you have to find out the stresses, right? But stresses calculation is not actually a core part of design of machine elements. Rather, finding out the dimensions to sustain the stresses actually is the part of design of machine elements. I hope you understand. Somebody can say yes or no whether whatever I talk is clearly conveyed to you in terms of clarity of voice. I mean to say.
Yes, sir. It's clear.
Very good. That's good. Okay, so this is the, I must say now, this is an extension of the strength of material as such. The various books which are available are Design of Measurements by Bhandari, very famous book. Every examiner, every student is aware of this book, Design of Measurements by V.D. Bhandari. Then few other books are machine design by Shigley. Shigley is another very famous author. Shigley, Khurmi is there. Machine design by Norton, machine design by Black. Sometimes where you have to use some design data book. Okay, what is the content of design data book? We will come to know later. But sometimes we have to use this design data book. So generally we use the PSG design data book. These books are important not only for reference, because it may happen that you will not refer it at all, because you will be more relied on textbooks. So no problem. Textbooks also are good options. I don't say it's not good option. But this list, the various books available on this subject must be known to us. As a student of this course is a subject. For a subject, we'll many times we'll say course for a subject. So the list actually must be known to you. I mean, few reference books must be known to you for this subject. Well, not for this, but for all subjects. What subject which you are going to learning, you must know few reference books. This can be whether you use it or not, that is a different thing, but you must know the names of the books which are very familiar among designers. Then, since the name is machine design, or to be specific, design of machine elements, we must start from this discussion. What is actually a machine and what is actually a design? Machine is a word which you are familiar because in STEM,
Excuse me, sir.
yes,
Sir, some students are still trying to join the lecture.
but they are not able to join.
No, they
Okay,
are in waiting.
okay, is it so? I will I will end this soon. Just wait. Now, uh, are they? They are joining now or not? Because I don't see anyone request here. I think they are joining now.
Yes, sir.
From your end, please somebody can message them that you try to join now. Is there anybody now willing to join and not being able to join?
Sir, Manas code is in waiting room.
But then I don't see any message here. Wait, I will. What I do, I'll stop recording because maybe because of recording, there must be some problem. I'll stop recording and then